Hello everyone. In this video, we will be evaluating trigonometric function, and this is the third part. I will put the link of the first and second part in the description box below. In this third part, the angle is in radian. Before we jump into some examples, let's have a review on some important information about evaluating trigonometric functions. First, we remember that reference angles are angles that are located in the first quadrant. So I actually cut this piece right here from the unit circle, and this is actually located in the first quadrant. As you can see here, there are coordinates for each of the angles here. So these coordinates are giving us very important information about this angle. We remember that the x represents the cosine of the angle and the y represents the sine of the given angle. So I'm just going to write that down here. Okay, so again, the x represents the cosine of the angle, and then the y represents the sine of the angle. So pretty much in this picture right here, we can go ahead and say that cosine 30 is square root of 3 over 2, sine 30 is 1/2, cosine 45 is square root of 2 over 2, sine 45 is square root of 2 over 2, cosine 60 is 1/2, and sine 60 is square root of 3 over 2. Now, please remember that these reference angles are very important because once we know the values for each of these angles, we will be able to determine the rest of the values around the unit circle. So again, we need to determine what is the reference angle of a given angle. So pretty much these are the formulas to determine the reference angle. So this is the formula that we use when the angle is in the second quadrant. This is the formula that we use when the angle is in the third quadrant. And this is the formula that we use when the angle is in the fourth quadrant. Now let's have an example to better see how this formula works. So let's have these examples right here. Evaluate the following and write your answer in exact values. We're supposed to evaluate sine of 2 pi over 3. There are steps that we need to follow in order that we can evaluate this type of problem. The first step is to change radian to degree. Since we're given a radian measure for the angle, we're supposed to change this to degrees. I'm going to show the work right here. So we are given 2 pi over 3. So that's 2 pi over 3. We're going to change this to degree. In order that we can do that, we're going to multiply this by a fraction of 180 over pi. So then from here, we can go ahead and cross out the pi and pi. So we are left with 2 times 180 is actually equal to 360, and that is over 3. So 360 divided by 3 is 120 degrees. So we already have crossed out the pi. So pi is gone. So 2 pi over 3 is actually 120 degrees. So after we have changed this to degree, we're now ready to move on to the second step. The second step is to label the unit circle and sketch the angle. So in this unit circle that we have here, we can go ahead and label this as 0. This is 90. This is 180. 270, and this is 360. Since this is all the way to 120, we can go ahead and approximate it. That's 90 right there. So 120 could be somewhere around here. So I will draw that angle and I will label this as 120. So this is 120 right here. Now, after we've created the angle here, we're going to move on to the third step. The third step is to determine the reference angle, and we evaluate. So we remember that the reference angles are the ones that are located in the first quadrant, and we actually have to use this equation right here in order that we can determine the reference angle. Now in this problem that we have here, 120 is on the second quadrant. Remember, this is the first quadrant, this is the second, this is the third, and this is the fourth quadrant. Since this is on the second quadrant, we are going to use this equation right here. That is the reference angle is equal to the angle corresponding to the negative x-axis minus the given angle. So in this problem right here, I'm just going to show the reference angle for this. So reference angle is equal to, that's 180 minus 120. So then we go ahead and say that our reference angle for this is 60 degrees because you have 180 minus 120 is 60. So we go back to the reference angle that we have here. So we're looking at 60 right here. The coordinate for this would match up to that of 60. So then we can go ahead and write this here as 1/2. And then that is square root of 3 over 2. And since this is on the second quadrant, the x is negative and the y is positive. So we can put a negative to the 1/2. Since we are looking for sine, we remember that the x represents the cosine of the angle and the y represents the sine of the angle. Since we're looking for sine, we are going to look for the y value. Remember, x is the cosine of the angle, y is the sine of the angle. So then we can go ahead and say that sine 2 pi over 3 is actually the y value, which is square root of 3 over 2. So this is our value for sine 2 pi over 3. At this time, I would encourage you to pause this video and try this problem out on your own. And when you're done, unpause it and check your answer. Okay, so we go over the problem here. Again, our first step is to change the radian to degrees. I'm just going to show the work up here. Okay, the second step is to label the unit circle and sketch the angle. Okay, and then we move on to the third step. The third step is to determine the reference angle, and this is located on the fourth quadrant. Okay, since this is on the fourth quadrant, our x is positive and our y is negative. Since we are looking for cosine, we remember that the x represents the cosine of the angle and the y represents the sine of the angle. Since we're looking for cosine of 7 pi over 4, that is actually equal to the x value, which is square root of 2 over 2. So this is equal to square root of 2 over 2. So this is the value for cosine 7 pi over 4. Did you get the same answer as this? Good. Perfect. Now let's move on to the next example right here. So we are supposed to evaluate tangent 19 pi over 6. So it's pretty much the same steps. The first step is to change the radian measure to degrees. I'm just going to show the work up here. Okay, so this 19 pi over 6 is equivalent to 570. The second step is to label the unit circle and sketch the angle. So I'm just going to label the unit circle right here. Okay, so 570 would be one turn of a circle is 360. So 570 should be between 540 and 630. So then I can go ahead and approximate it to be somewhere around here. So this is 570 right here. So let's go all the way to 570 and label this as 570 degrees. So we need to figure out what is this coordinate. So then we go ahead and move on to the third step. The third step is to determine the reference angle and evaluate. So this is on the third quadrant because again, this is the first, this is the second, this is the third, and this is the fourth quadrant. So I'm just going to show the work for the reference angle right here. Okay, so the reference angle is 30. So this would match up to the coordinate of 30. So I can go ahead and label this as square root of 3 over 2 and 1/2. Now, since this is on the third quadrant, the x is negative and the y is negative. So both of these are negatives. Again, we remember that the x represents the cosine of the angle and the y represents the sine. But in this problem, we're supposed to solve for tangent. Now, we remember that the formula for tangent is... Okay, so I've set up the fraction that is y over x. So then if we have a fraction over a fraction, we're supposed to flip the denominator and multiply across. So this would come out negative 1/2 times, flip it, that would be 2 over square root of 3. So then we are left with, we can cross out the 2 and the 2 here. We are left with... This is a negative right here, so this will come out a positive. So that is a positive 1 over square root of 3. Again, this is a positive because negative multiplied by a negative is a positive. We can rationalize this since we are not supposed to have a square root on the denominator. We can multiply this by square root of 3 over square root of 3. So then we go ahead and say that 1 times square root of 3 is square root of 3 over square root of 3 times square root of 3 is square root of 9, and square root of 9 is 3. So then this is the value that we have for tangent 570 or tangent 19 pi over 6. So this is equal to, again, square root of 3 over 3, and it's positive because this is on the third quadrant. The tangent here is positive. At this time, I would encourage you to pause this video and try this problem out on your own. And when you're done, unpause it and check your answer. Okay, so we go over the problem here. Again, the first step is to change the radian to degree. I'm going to show the work up here. Okay, so this 15 pi over 4 is 675 degrees. The second step is to label the unit circle and sketch the angle. So I'm just going to label this unit circle right here and the angle as well. Okay, so once we've labeled it, we move on to the third step. We determine the reference angle and we evaluate. So this is on the fourth quadrant. So this is first, this is second, this is third, and this is fourth quadrant. So we're going to use the formula for the fourth quadrant to find the reference angle. Okay, so we got 45. So then we go ahead and look at 45 right here. So this 675 will have the same coordinate as that of the 45 degrees. So I'm just going to write that up here. That is square root of 2 over 2 and square root of 2 over 2. Now we remember that on the fourth quadrant, the x is positive and the y is negative. So I can label this as negative right there. So then we go ahead and determine the tangent. Now we remember that the x represents the cosine of the angle and the y represents the sine of the angle, but we wanted the tangent. Now we remember again the formula for tangent. I'm just going to show the work up here. So I plug it in. We remember that this is the x, this is the y. So our y is negative square root of 2 over 2. And then the x is a positive square root of 2 over 2. So then we can go ahead and say that since these are the same numbers here, this is actually equal to 1. And that is a negative 1 because we have a negative over a positive. So tangent 675 is negative 1. So I put a negative 1 right there. So this is the value for tangent 15 pi over 4. Did you get negative 1 as your answer to this? Good. Perfect. If you find this video helpful, hit like and subscribe for more math videos. See ya!